Right, today we're going to do paper 2 now from 2022. So the first question is an acidified solution butanone reacts with iodine as shown below. Okay, this is draw the displayed form of this. So all you have to do is draw the displayed form of this. Give the name of your displayed formula. So this is a displayed formula drawn. So you must show every bond in a molecule. Okay, that's a displayed formula. And the name is 1-iodo butan 2-aln. So the first question. Now question 1, 2. The rate equation for the reaction is this. So they give you the rate equation. Rate equals K when you got your butanone, and then you got H plus concentration there. Then they give initial concentration there. So the initial rate of reaction experiment is this. They give initial rate. Calculate the value of rate constant K in for the reaction and give its units. So you rearrange this K. So if you rearrange K, go rate divided by the concentration of both. You place the values on them. Once you have the values, you end up with the answer being 0.00004L4 or 4.04 times 10 minus 5 mole per dm cube second. No, that one is just mole per dm cube. And then the units, when you do the units, because you have the rate on top, which is mole dm cube second minus 1, divided by mole dm cube squared, you cancel one each side. It ends up with 1 here, s minus 1 divided by mole per dm cube. So if you bring that up, then you go mole minus 1 dm cube second minus 1. Okay, so that's how you do that question. So question 1.3, calculate initial rate of reaction when all initial concentrations are halved. So if you halve the initial concentrations, you get the rate. So you got to half everything. So you have 4.04 times 10, which is the K, times 2.1. So I halved everything, half of that times a half of that. Okay, and then you end up with rate equals to that. So rate equals 3.625 times 10 minus 5 mole per dm cube second minus 1. So that's the answer to initial rate. Question 1.4, an experiment was done to measure the time taken for the solution of iodine to react completely when added to an excess of acidified solution of butanone. Suggest observation used to judge when the iodine had reacted. The color changes from brown, which is the brown from iodine, to colorless when iodine just reacts completely. Okay, so that's the answer to question 1.5. It says to describe and explain the shape of the graph in figure 1. So we need to look at figure 1 and describe it basically. That's for 3 marks. So as t increases, 1 divided by t increases by a greater factor. So as the t increases, temperature increases, this increases by a much bigger factor. There are many more particles that have an energy greater or equal than activation energy. So therefore more successful collisions will occur. Okay, so that's 1 mark to 1 mark and 1 mark for that one there. So we're looking at this graph there, and then you're describing there. Okay, then it says deduce the time taken for the reaction at 35 degrees. So you got 35 degrees here. You find 1 divided by t per second. You put 1 divided by 0.03, which it shows in this graph there. Okay, and then if you calculate that, gives you 33. 1 divided by 0.03 gives you 33 seconds, and that's how you answer that question. Right, question 1.7, that's for how many marks? 5 marks there. So it says for different reaction, table 2 shows the value of a rate constant at different temperatures. So you got all the values here, temperature in Kelvin and rate constant. Then it gives you an equation here. Okay, so this equation can be used to calculate activation energy. So you've got to use this equation. Calculate the value in kilojoules per mole of the activation energy. The gas constant is this, they give you the gas constant. So you take the equation and you replace the values that you have. Okay, so you got ln of 1.55 times 10 minus 5 divided by 1.7 times 10 minus 7, which is K1 and K2 shown here. And then that will equal to EA and constant times 1 divided time 2, which is this one here, 333, and 1 divided time 1 is 303. Okay? So you place all these equations, set up the whole equation, you rearrange this equation, so you work that out, rearrange this equation, then you rearrange to find EA. Okay? So once you have, so you set it up, you work out ln of those two, gives you that value, gives you EA divided by R. You know what R is, and you got times by this value here, which you calculate with that. Okay? And then you have EA equals to that value there, divided by that value there. So EA is going to give you in joules, but because they want the kilojoules, you have to divide it by 1,000 and gives you 66.9 kilojoules per mole. So that's the answer that you get in there. Right, the next question is a mechanism. Name and apply the mechanism of the reaction put on with KCN followed by dilute acid. So this reaction is a nucleophilic addition, so it's something added from a nucleophile. That's a nucleophile is been added to that carbon, which is positive. That O becomes delta positive, delta negative. So curly arrow goes always from negative to positive. Another curly arrow goes there, so the number of electrons, the pair electron moves towards the oxygen. The next step here, you put exactly the same, so the lone pair in oxygen becomes negative there. That's been added, okay, so that will be attracted to H plus, right? And then it forms the OH attached to that, and that's your final answer, okay? Those hydroxy nitrile there.